we are going to measure it in a way that we use best fit. Anytime that we use an AFscan tool, it is going to best fit a line or a diameter through that. I want to show you guys some tools to use when we're setting datums the way that we should be setting datums, using mating features, mating envelope of the part, where the actual part is going to mate with your part or vice versa. Where, you know, if we have a diameter, a through hole, we're going to use a pin gauge to put a pin gauge in there to check it, or the microview to check it. And that pin gauge is going to be the largest pin gauge that we can fit into that diameter. But when we use microview and we scan 100 points around that diameter, we're going to best fit all 100 points around that diameter. And we actually could have different sizes between our mating envelope and our AFscan circle tool on there. So let's go ahead and jump into this here. I'm gonna come over here. Just some housekeeping as always on all these webinars. Remember, I record these webinars and post them on YouTube, so you can go look up ATI Metrology training channel. We'll be putting this video, and there's roughly about 20 other videos about the microview systems on that channel, and more to come with that one. We have metrology training courses coming up. This is our March calendar, Friday the 3rd, right here. We have our free microview webinar next week. We have open registration classes for CMM Manager. If you guys have that, we can use CMM Manager as an offline seat with the microview, or if you guys have any CMMs in your shop, they might be running CMM Manager. And then the week of the 14th, we'll be here at Elgin with some hand gauge usage, blueprint reading, and some GD&T fundamentals registrations open for all those. And close to the end of the month, we'll be down in Indianapolis, looking same classes down there. So if you guys are in the Indianapolis area, feel free to email me for any information over there. And then looking at the April, we have some microview classes coming up in April here at Elgin, and then we'll be in our Warsaw facility for some classes as well. Some of you have emailed me. This year we launched microview level 1 and microview level 2. A lot of you have been through microview basic and advanced training with ATI. We have took some of the advanced training and brought it to level 1. So level 1 is basic class, the 4 hours, and we took about 2 hours worth of advanced class and brought it into level 1, because we kind of felt like this was the level 1 information that you needed, even though it was in the advanced class. And then that gave us some room with the advanced class to make level 2 of the advanced features, then expand on a lot of the advanced features and dive deep into even more of the advanced features as well. So if you have taken basic training and advanced training, I would say if you're looking at these new classes, level 2 will be a nice review for you and some additional information that you didn't get in basic and advanced. But if you haven't been through either of them, level 1 is a great place to start there. Just also a reminder, we're more than just microview training and metrology training. We do microview programming, CMM programming, third-party inspections. So if you guys have too much work or too big of parts for your CMM or microview, you guys can send it to us, and our inspection team will be able to measure your FAI, PPAP, whatever that might be, send you back reports. We do reverse engineering. So yesterday I was actually in training, and we were learning a Creoform handheld scanner. It's pretty slick stuff. It's our first handheld scanner that we've had at ATI. It's going to help us a lot for large part inspection as well as reverse engineering. And then we also have some engineering solutions if there's anything you need, fixture design, custom gauges, stuff like that. This year is Quality Show in October. We'll be in Rosemont at the Quality Show. We've always had a booth there showing off all the equipment that we sell, service, calibrate, and train on. And this year we're actually expanding to another booth, and we're going to have a hand gauge zone. Come over with your parts, learn how to measure GD&T with basic hand gauges like indicators, micrometers, height gauges, and such. I will be sending a link after this webinar. You can register through our website. You'll get a VIP code, so your registration is free to the quality show. So you guys will hear more about that later on. Last month, we talked about stitch snapshots, exporting snapshots, talked about multiple systems. So these videos, I split it up into part 1 and part 2. It was a little longer of a webinar, but these are on our YouTube channel, so you can go over and look at all this. And we talked a little bit about if we see profile, parallelism, and flatness all on one call out on one surface on our blueprint, what do we do? So we looked at that. Today, what I mainly want to focus on is semi-automated program best practices and also setting datums as mating features. It's a big thing of not using best fit when honestly, I'd say about 80% of our quality teams are using best fit features to set their datum, set their systems as it. But sometimes when we do that, we send off our reports and our numbers might be slightly off with our customer. And our customer supplier might be using, not best fit features. They might be using like inscribe circles or actual mating features to set their datum. So I want to show you kind of a couple tricks in the microview to establish these. Am I telling you to go to your microview today and switch all your programs? No. If your programs are running fine, your data is awesome, your customer supplier is happy with your results, there's no, rocky waters going on, don't switch up what you're doing. But if you do have an engineer, other quality team, manager, whatever it might be, that comes to you and says, hey, we're actually measuring this diameter as an inscribed circle or a circumscribed circle, these are the features that you want to do. Also, when we talk about lines, if we're setting skews, we want to make sure that we're setting skews to maybe not the best feature, maybe the most two max points on that line or feature right there. So as I'm going to do these programs, I'm also going to talk about our best practices for setting a semi-automated program. So the program I'm going to do here, I'm going to try my best to keep it a semi-automated program for our best practices with that. So since I'm doing a semi-automated program, and just as a review for those more beginner programmers and users of the microview, the difference between a fully automated program and a semi-automated program is the fully automated program, the part has to be in the same spot every single time. So if we don't have the option to have the part in a fixture, same spot every time, that's when we have to do a semi-automated program where we can't start off with recalling a feature. You guys might notice I have microview glass in here, stage square. If you've never seen storing features permanently, we have that in past webinars. You guys can go back and review those, but those would make the program fully automated because our features list would start with a system. So we're going to do a semi-automated program and we're going to set some datums. So let me show you the difference between setting a best fit and an inscribe. So a circumscribed circle is typically used to measure a standing feature like a post, and we'll tell you what is the smallest ring. So if you guys ever use ring gauges and you have a post, you would find the smallest ring that would fit over that post. Now the opposite with a through hole, that's going to be an inscribed circle. An inscribed circle is typically used to measure a hole and will let you know what is the largest pin gauge that would fit through that hole. So we have a through hole right here. So I'm going to go ahead and I'm going to click circle. I'm going to do more inputs because I can't see this whole circle in the camera window. So I'm going to have to use multiple AFscan arcs to measure this. So I'm going to go ahead and hit more inputs and AFscan arc. And I'm going to scan an AFscan arc right here. I'm going to flop my arrows over going from black to white. If you've been on plenty of these webinars, I've talked about it doesn't matter if you go light to dark or dark to light. We want to go from less noise. So we have all black here and some white here, but we also have some noise going on here. some other gray values. So I want my arrows to go from black to white on there. And since I have the more inputs tool selected, I can just go around here and I can measure a best fit diameter. So I'm going to right click in my points view and I'm going to open up a large points view so you guys can see. So I got this here. We can see, if I zoom in here, we can see that this green line going through all these points is our best fit diameter, but we have some deviation from best fit going on. So it's going to best fit that diameter through, I took 4 AFscan tools, so we probably have about 400 points around this diameter. So that's best fitting that through hole right there. But if we exaggerate these points, we see that the actual form of this part, there's going to be 3 points on this inside diameter that's going to create the physical mating envelope that if a pin gauge went through here, that's what's going to hit onto there. So a couple examples with that. So this is some slides from our 2-day GD&T fundamentals class talking about datum, datum feature simulators, and simulated datums. So when we're using hand gauges and hard gauges and gauge blocks and whatever we might be using to establish datums when we're measuring it with calipers and micrometers, is we got this workpiece here, this physical part that came out of your machine, a little exaggerated. Hopefully you guys aren't making parts this bad. But we see that if this was datum A, this bottom plane, it's going to make 3 points of contact onto our granite plate. So we have our datum feature, which is our physical produced imperfect part. We have our datum simulator. So we have our datum simulator, which is our granite plate. And the 3 points of contact that make from our physical part, the 3 points of contact onto the granite plate, we're going to create a datum and a simulated datum plane where it's actually hitting onto there. Now with a through hole, we use a pin gauge. The pin gauge is going to fit through this hole, and we see that there's 3 points of contact. So we got 1, 2, and 3 points of contact. But that's the largest pin gauge that can fit through there. And that creates the mating envelope. Now we also got some other local sizes, which we won't talk about today, but if we best fit this diameter, we would have a way different diameter than we would with this pin gauge. Now when we talk about slots or gaps, keyways, whatever you guys call it, we might use a gauge block to see what points are we contacting over here and what points are we contacting over here. Because when something mates into our blue part, it's going to make contact with the sidewalls. It's not going to make contact over here, but we might be, if we scan this whole thing with an AFscan tool, we would be best fitting it through all that deviation. And that's not the true functionality of our part, right? So with this diameter here, this is a best fit diameter. If we want to set the mating feature of it, I can click circle. And I can come to my inscribe tool right here in the red icons. And I can click on that circle. So there's 2 ways to do this. Notice our points view, how it switched from the best fit to now that green diameter is going to be our largest pin gauge that would fit through there. Now I started to say we could do this in 2 ways. If you want to get your best fit circle and then pull an inscribed circle out of that data, that's one way. I like doing that because then I have both options sitting there. But if you really wanted to, we could just start off with circle, keep that inscribed construction. I like to describe these as like filters almost. So it's going to filter the data that we measure, those points, and put that inscribed circle there. But we could just start right off with that all of our scan data is going to inscribe when we measure it. So we can see here that we just click circle, inscribe, and then we went and measured it. and we got an inscribed circle here. You could also do the opposite where I click circle, turn off my inscribe, click on that, and then it makes a best fit. So it's just taking all that raw data. Every single one of the points has an X, Y, and Z value in there. So it's just going to take that data and put the filter, put the construction tool that you want on there. Because if we look at, go back to the slideshow here, if we look at this, if we took this diameter right here, this largest pin gauge, the actual functionality of this diameter that we were putting a pin gauge through, that center of that pin gauge is probably going to be different than the center of our best fit. I can almost guarantee you that they're going to be different. Even if we're off, let's say, if we're talking inches, even if we're off 0.2, that 0.2 over so many inches could throw off a true position measurement onto there. So we just got to be real careful with this. I'm going to go ahead and delete that guy. We got our inscribed circle here. So I'm going to rename this. I'm going to call it Datum diameter B. Let's say it's that one. And I'm going to rename this best fit diameter B. Just so we can keep track of it in case we see, and let's look at the different diameter sizes. So best fit diameter, we're looking at 0.322. And if we look at our mating diameter, so we're losing about 2 thou, a little over 2 thou, right around 2 thou difference of diameter size, which size isn't location, but you can imagine that if we're 2 thou difference in size, how different our location is going to be on there. So if we do that, and then let's come over this other diameter, and let's do that again. So I'm going to come over here, I'm going to hit autofocus, get that edge in focus. Failed out on me, but the edge looks pretty good there. So I'm going to do a circle. I'm not going to put my inscribed on yet. Hopefully that sawing isn't too bad for you guys. I apologize. I can't wait for you guys to see our new Elgin location. For those that are around the Chicagoland area, we'll have an open house at some point. But walls are going up for our new lab, and inspection is going to be great. So this is going to be my best fit diameter, and I'm going to say that this is datum C. That's what my blueprint says. And I'm going to hit circle. I hit inscribe. I'm going to click on that diameter. So I'm going to take all that scan data and just format it, fit it to what a largest pin gauge would be. So I'm going to call this mating diameter C, so I can keep track of my datums. And then I can easily skew, and I can click on my 2 mating diameters, and then I'm able to set my skew to that guy because I have my 2 diameters, datum B and datum C right here. Just as a little experiment, I don't know if we'll see any difference between the two, but I said, looking at the centers of them. So if we come over here and we look at, this is our datum B, I'm going to click on a point. I'm going to click my best fit diameter. We see our point right there for the center point of our best fit diameter. Now I'm going to click point. I'm going to hit mating diameter. And let's really zoom in on that to see how far off we are. You can see that we're slightly off of each other. So it is changing the distance, or changing the center of it. So let's go ahead and do a distance between the 2 points. I'm just interested. Yeah, we're looking at in X 0.3 and Y 2.5. Difference in center points doing a best fit and a mating envelope type of diameter using the inscribed circle right there. So those, if you add those together, how far off could a true position be, on the other end of the part? You got to be real careful with this because this is going to change our results in what you do. So again, the reason I wanted to bring this to you is that there is, quality teams out there, inspection teams out there, engineering groups out there that use only the mating features. They use inscribe, circumscribe. Majority of the quality teams that I've had experience to talk to is just doing best fit features on there. So if something comes up in a discussion with a customer, how you guys are measuring it, these are the tools that we can do. Now I got a post over here, drive the machine over. I'm gonna go ahead and turn on my surface lights. So using inside diameters, through holes, blind holes, things like that, something that if it's a diameter that's going to be accepting a mating part, we want to use inscribe. Now, if we are going to be doing something on the outside, so if our part is an outside diameter, if our part's going to be mating into something, we want to use the circumscribe diameter feature right here. So I'm going to do a circle. Again, I'm going to use more inputs. Scan this outside. Now I got my best fit diameter here, so this is going to be my best fit diameter post. And then I'm going to go ahead and click circle, circumscribe circle, click on my best fit, and then we can see now that our green diameter is on the outside of all those points, because that would be the smallest ring gauge that would fit over this post. So there's 3 points, one right there, one right there, and one right there, probably, yep, one right there. That's where the ring gauge is going to make contact onto that. So let's go ahead and look to what difference between the two is. I'm going to do a point, my best fit. I'm going to do a point to my, I'm going to come over here. I'm going to zoom in. This one's pretty close, but let's take a look at the distance between the two. We're looking at 50 millionths in Y and 130 millionths in X, a tenth and 30 millionths there, with an XY distance of 14. So yeah, so not as much of a difference on the inscribe, just a different machine part. It's not stamped, it's not punched. This is machined. So maybe a little, better process on this part here, but we can see that there's still slightly a difference between the two. If we look at our circumscribed and then our best fit one, slightly off. But again, this could throw off our results. So these are filters, these are construction tools that I use as best practice, just because I know that if this outside diameter is going to be mating into something, I want to use the circumscribe circle. If I'm going to have an inside diameter that's going to be receiving something, I want to use the inscribe circle. Now, in all my experience with MicroView, I have tried a million different ways of getting this type of measurement with a line. The best route I can find is what I'm going to show you next. If you guys have any other experience with doing something like this with a line to get what the actual point of contact will be, I'd love to get an email from you, because this gets brought up a lot. And I'll show you why I'm not 100% confident in my best practice here that I have found, but the results are always what I want. I haven't had anything come back because of it, but I would love to find a better way than what I'm doing in this instance. So we got this edge right here. And if something was going to go into this slot feature, I'll show you guys this slot feature. We have 2 straight edges and 2 radii. So if something was going to go into this keyway right here, there's going to be 2 points of contact on this side, and there's going to be 1 point of contact on this side, or vice versa, that part that's going to be going into this is going to hit. So I'll show you what I do first. Actually, let me show you this. So if I do a line and I do an AFscan line and I do more inputs, my first thought when I was trying to figure out the best way to accomplish what's going to make contact on this edge, I'll scan this whole line. Let me get rid of the rest of this junk here. So I got this line right here, and we got all these random points, not random, but scan points that's making a best fit line. See that green line right there? It's making a best fit line through all 100 points right there. But we can see that we have a point here and a point here that are going to be our worst cases. Now, my first thought was if I come down into my points view, I exaggerate this, I can right click on this point and I can move to that point, and my crosshairs in my camera window will move exactly there. So I can do a point and I can do best edge, hit the space bar, and it's going to take a point right where my crosshairs are. So I got a point there. Then I can come back to my line. I'm like, okay, this is the second worst point. So I'm going to come over here and I'm going to move to that point. And then again, I'm going to do a point, best edge, and take a point there. Now, the problem with this is that this isn't going to be automated. If I have 10 parts, these points are now going to hit in this XYZ location that I told it to. It's the microview is not going to automate and find the two worst case inside features. And the reason I say inside is because this is an inside feature right here that something's going to be going through it. Now, if we were going to be doing this on the outside edge, again, you'd look at like what's the farthest to the right if it's the right side of the part, farthest points to the left if it's the outside left edge of the part. So with this isn't automated. These are going to be put in this location, but next time the high point might be over here. So we want to see, I wanted to figure out a way to make this automated. But we got these 2 points right here. I can do line. I can click on my 2 points. And now I can create a line that is going to be the 2 points of contact that a mating feature coming into it is going to make contact with. But again, not automated. So I don't like that. My next thought was go to line, more inputs. I can scan this. And I can scan the rest of this here. We got this long point. Now, I've shown this a couple times before. I'd really encourage you guys to explore this. If I click point cloud, I click on that AFscan line that I did, it extracts all that data, the XYZ data of this, to where it's not fitting a line or anything to it. You can see in my slider bar that it's not exaggerating those points. Those are just the points extracted from the AFscan to make this point cloud. Now I can click point and I can click on that point cloud and I can ask for the maximum or minimum point in X, Y, or Z going on here. So knowing this, I could come to this line, I can skew to this best fit line. So when I hit my PCS view, I can see it goes straight up and down. Now when I do my point cloud and I click on my line, extract all that data, I click point, I click on my point cloud, and I could say I want the minimum in X because I want what is going on in the left direction, what's the most in the left direction, but I only get 1 point onto there. So this drove me to going to do sections of my line. So this little feature right here, I'm going to do one AFscan here, and I'm going to do an AFscan here, and then I'll do a skew to one of those so I can know which is my X direction negative and which way my positive X direction is. And then I'll extract my point clouds from both of those lines. And then I can ask for a point, and I click point cloud, and I ask for my minimum X. So I want to know what's the going in the left direction. I got a point there, click OK. And I click point again. I extract it out of point cloud 5. I ask for my minimum in X. And we can see that the farthest point to the left gets highlighted. And now I can click line. I can click on my 2 points, and I got this line right here that creates my most left edge points going there. Then I can come over to this side, do the same thing, get this in focus. Doesn't like that. And I'll do the same thing. I'll do line, AFscan, scan this edge here, scan this edge here. Again, I'll extract my point clouds out of those 2 lines. And then I'll click point, and I'll extract my point out of my point cloud. This time I want my maximum in X because I want to see what's the maximum on the right side. I click OK, I click point again, I click on my second point cloud. It's giving me the maximum in X in the right direction. And now I can click line and connect those 2. So now I got 2 lines right here. Now I can do a line of bisect between those 2 lines. And that's giving me the center line of my 2 mating features, my 2 mating envelope, what something actually would be fitting into this part. And now my center line is off of what that actually would be, and the functionality, the fit, and the form of my part right here. So then I can set this as my skew or whatever datum this one would be, and we're good to go out of there. If this is all new to you of setting mating envelopes and best fit and that kind of stuff, I would encourage you. Our 2-day GD&T fundamentals class is a great foundation if you just have a general idea of GD&T. We dive deep into all this kind of stuff of what actually mating envelopes, datum features, simulated datums, all that kind of stuff, and how to measure all of that. So I got this couple different features that I've shown you of, okay, inscribed, circumscribed. I'm going to do these point clouds to get the mating envelope of this slot or this edge, whatever it might be. So now let's put all that into one big system. So I'm going to create a semi-automated program. And this is where a couple tricks that I've learned actually through training you guys. You guys tinker around with the microview and you guys find these cool little features, and I take a picture of it while I'm in training. I'm like, I'm bringing that to my next webinar because it's kind of a slick tool right there. So let's go ahead and put all this into practice. So if we look at, I'm going to call this a datum. So I'm going to do more inputs, and I'm just going to skip right straight to my inscribed circle. Let's say that I don't care about my best fit. I want to know what my mating envelope is going to be. So now I know what the largest pin that would fit through here would be. Now I'm going to come over to this. So if we have on my blueprint, this diameter is datum B, so it's going to be my origin of X and Y. And then I still need a skew for my alignment. And so datum C is the center line of this slot right here. So to make my life easier, we talked about this in the last webinar, is I want to get my program up and running as quick as possible. I want to do less work for a semi-automated program, because a semi-automated program, I have to do all the work up until we get a system set up. So I'm going to do a circle, and maybe this circle really doesn't matter. This circle is just, we're going to report the diameter maybe. We really don't care about it. So it's going to be part of my system. Got more inputs. So it's going to be my first kind of locating system. So all I'm going to do is my origin my left diameter, and I'm going to skew real quick to these two diameters right here, just to get a locating system. So this is just my locate system. But this isn't part of my datum. This is a datum. Let's call this one datum B. And then we need that center line of that slot to be datum C. So now I'm going to do what we just went through, and I'm going to find out where are our two most points here. I'm going to do that AFscan line here. I'm going to do an AFscan line here. And again, since we have a system set up, all of this is going to be automated. When I did those best fit or best edge points, that wasn't going to be automated because it was storing those X, Y, and Z locations of those best edge points. But doing it this way with these point clouds it's going to automate it. When I ask for this point cloud and I ask for a point minimum in X, which it's not giving me that point right now because I need a different skew going on there, it's going to automate this window. So every time that we measure a part, every time that we put a new sample on there, it's going to find the minimum or maximum point in X that we asked for, and it's going to automate that. So that point's going to move around because every part's going to have a different mating envelope. So when I measure all these lines here, I'm actually going to do a second system of just skewing it's going to set my skew to this edge right here. So now I can ask for my minimum point. So now I'm going to extract all my point clouds. And then I can ask for my points out of those point clouds. I'm going to ask for my minimum because this one, this point cloud right here, I want the minimum going in that direction. Same thing with this point cloud right here. And then I'm going to click point. I'm going to ask for this point. I'm going to ask for the maximum. And then same thing with my last point cloud is I'm going to ask for the maximum in X. So now I can come over and do lines between those. And very last thing, to get that center line, I'm going to do a line, bisect of my two lines. Now I have the mating envelope center line of that feature there. So the last thing that we need to do is build our actual datum structure. So I'm going to do origin to my first diameter, datum B, and then I'm going to skew to my center line. Now, most likely this blueprint would probably have, some sort of 45-degree offset. Let's pretend that it does have that. So since this is our skew, but our blueprint has everything dimensioned off of straight up and down, I'm going to come over to my offset button right here down at the bottom of the red icons. And I'm going to offset this. Let's see if it's 45, how that looks. Oh, wrong direction. See how it went that way? So if I come back into here and I do a -45, watch this system icon over here to the left. Now it goes straight up. So when I hit my PCS view, we're straight. It's probably some random angle that we have. I don't have on the blueprint in front of me right now. But we see that now we're lined up with this at a 45, good to go there. All right, we got an automated or semi-automated program. Now I release this to my factory floor. We have 10 operators on the shop floor that can run these programs. If Sue comes up, she puts the part on there. How is she supposed to know how to measure this? Semi-automated program, if I hit the run button, yes, I have a black crosshair right here, but also that might not mean anything. This prompt right here comes up, says the next tool must be located manually. After measuring, press continue or the enter key. What I recently learned is that if I go to my circle, I come down to my inputs and I right click on my input and I go to edit prompt, I can type in place an arc on the 12 o'clock of left diameter, whatever instructions that you want to do. And then now when I hit run, that little note pops up right here. So instead of putting work instructions or like a PDF that pops up, if you don't know how to make a PDF or a picture pop up, you go to feature drop down menu up here, insert command line, and you can have a picture pop up. Instead of doing that, we can put these little instructions into our programs. So if you teach your operators that they don't need to know how to program, if you have a shop like that, and you just want them to run your programs, just write them little instructions going on in here. So also for myself, we do third-party inspections. So you send me a part, and maybe I don't see that part I see it once a year. You send it to us for an annual validation or an annual PPAP, whatever it is. I don't remember how I measured it last March. So maybe I put my own little instructions in here. So if I don't see that part for a year, a couple of months, I remember what I did, how I programmed it, that kind of thing. So nice little notes that you could put in for per input. So if I do this, I hit run. Maybe you can put in there to make sure edge is in focus. Now when I hit continue, that note goes away. And maybe I want to say in this input, I go to right click, edit input, and I say place an arc lower right corner of circle, if you really want to confuse them with corners of circles. So now when we run this, again, we can place the arc on the top, hit continue. Now it says place an arc lower right-hand corner right there. Cool little trick that I learned in training from a company that came out, and we were doing some training on the Microview. They have a sole. And so especially with Microview soles where everything is pretty much, you're the motor, so everything's moving on yours. And you're able to do that. I just saw a question pop up as we're actually wrapping up. That was the next thing I was going to say is any Q&A that you guys have. Let me look at this chat real quick. There's a feature to snapshot every feature automatically. Let me know how to make that work. So if you want to, yes, we might have talked about this in the last one. I'm not sure, but let's go and find something real quick. I'm going to turn on service lights. Yeah, if you guys have any other questions, anything I've talked about, or any other random questions, feel free to pop them in the chat box. I'm going to go ahead and just scan this. So if I measure this circle here, do file new, circle, AFscan circle. So if I right click on this circle, or I can hit F4 to open up exports. Coming down here, it says export snapshot. If I do that drop down menu, we can do if measurement fails, if it's out of tolerance, always. So what I commonly do is I will do if it is out of tolerance, because I don't care if it's good. I just care if it's out of tolerance. So I will do export snapshots if it's out of tolerance. So now when I close this, if I go to tools, playback options, and I come to export snapshots, we can pick a folder that those snapshots will save to. So if I'm running 100 parts and 3 diameters are out on those 100 parts, I'm only going to get those snapshots for those failed parts. I'm not going to get a snapshot for every single diameter. Your IT is going to be very mad at you because filling up your server with a bunch of JPEGs could be bad. But if you have a customer that wants you to document every single measurement you take, you could, when you export features, you could say export always, and you would get that. So hopefully that answered your question there. See some other questions here. Zone 3 programmer, that's one software, not one, there's plenty of softwares I haven't done, but I do not know that software. Let's see what you got. I'm used to manual soft alignment transferring to hard automatic alignment. This way you can put the part anywhere on the stage. Can this be done with Inspect? Yes, this can be done with Inspect. So what I did in that last program where I took the 2 diameters, set a system to those 2 diameters, then I went and did a better system with my Datum C. As soon as there's a system set up in our features list, that'll create that's where it starts going automated. So I just need to measure those 2 diameters, real easy diameters, to set a alignment. That's my locating system. And then after that, I set a datum system. That datum system is a better, more controlled, more, maybe even the datum is what it's supposed to be. And then everything is going to be looking at that parent system up here in the top right. That parent system is what your features are looking at. So your locating system wouldn't really matter. And then once you set your datum system, after your datum system is set, every feature underneath that is going to be looking at your datum features. So yeah, same thing. I like that verbiage. I don't think wordage probably isn't a word. My English teacher brother would be mad at me. That soft alignment transferring to a hard automatic alignment, exactly. That's what it does. So you can set as many systems. If you go on our YouTube, the January webinar that I posted, I think I posted it this week. The January 2023 webinar that I did talks a lot about that. So that'd be good for you, Chris. Yeah, as we're wrapping up here, just a couple things. If there's any other questions, pop them in here. I'll finish up the rest of the housekeeping. If there's any other questions, I'll go ahead and answer those. You guys can scan this. You can scan this QR code. It'll bring you to our events page, or it'll email me. And to sign up for any of these classes, check out when they're coming to near to you. In May, if you're a Wisconsin customer of ours, bringing our training seminar up to beautiful Fond du Lac, Wisconsin. It's been about 2 years since I've been up there. So we'll be bringing the training seminar up there in May. And then also we offer on-site. So if you have any on-site needs, if you have 4 or more trainees that you want me to bring any of our classes on site, we can do that. Blueprint training, as of right now, is not offered online. But I have been investing in equipment for the training room to be able to offer it online, like online seats. So keep your ears out for that, James. Eyes out for that. Again, Quality Show, I'll be emailing all of you guys a link to register for Quality Show. I know it's ways out in October, but it'll be here before you know it. Be good to start planning ahead for Quality Show. Come walk the show floor, see, you know, Mid-Atoyo has a huge booth. We have a big booth. A bunch of other companies have big booths. See my manager, good friend Nate with QXsoft. They'll have a booth there. And come see me and the rest of my team at the hand gauge zone. Learn how to measure GD&T using indicators, micrometers, stuff like that. So yeah, thank you guys for joining today. Sorry about the background noise if you guys heard any of the construction